let's work a bond valuation problem that asks us to compute yield to maturity. The problem appears in gray in front of you. Wilson Wonders bonds have 12 years remaining to maturity. Interest is paid annually. The bonds have a $1,000 par value and the coupon interest rate is 10%. The bonds sell at a price of $850. What's the yield to maturity? Okay, in this demo, I'm going to solve it using two different ways, two different functions within Excel. First, let's take advantage of using Excel's rate function. To do this, we need a number of values completed. To save typing, I've typed some of it off to the side. Okay, we need to solve for the number of periods. It's 12. The present value is $850. And with this function, we need to enter that as a negative. That would be the cash outflow it would take to purchase the bond today. The interest payment, we can calculate that as the 1,000 par value times a 10% rate, or $100 is the interest payment or the coupon payment. And the future value of the bonds that we expect to get is $1,000. Okay, and what we want to do now is solve using Excel's rate function. And I'll just walk through this off of the formula bar so we can all see it. Okay, the number of periods is the 12. The payment amount is the interest payment of $100. Present value would be what the bonds are selling for today, entered as a negative. Future value is what we expect to get for the bonds when we sell it, entered as a positive. And the type we can leave blank, which refers to if it occurs at the beginning period or at the end of the period. And all the bond problems, this occurs at the end. So when we're done, we have the answer of 12.48%, and we've solved the yield to maturity using Excel's rate function. And let me bold that so we can tell that that's the answer. Now another approach would be to use Excel's internal rate of return. And sometimes this is the easiest way to lay out this type of compute the interest rate problem. In this case, what we want to do is lay out the cash flows when they occur. If we were to buy this bond today, it would cost us $850. We enter that as a negative because it's out of pocket. Then every year for the next 12 years, we are going to shell out, we bought the bond, so we would take in $100 of interest. Let me enter that as an absolute, and then I can copy that down. However, in the last year, we also get $1,000 back. Now, let me just format this a little bit better. And then we can use Excel's internal rate of return as a way to solve the yield to maturity problem. Equal IRR, left paren, let's call it up over here so you can see it walk through it. The values now is that stream of payments, and you can enter it that way. Excel knows what to do with that. And the guess, I'm going to use the coupon rate of 10%. It just needs a guess to get us started. And when we hit that answer, we get 12%. Let me bold that and get the decimal place, and you see that we come up with exactly the same as we had before. Let me shrink this a little bit so you can see that a little bit better. Okay, so in this example, we're effectively calculating the effective interest rate using either Excel's rate approach, that's this technique over here, or you could use internal rate of return.